right, 1 and 2, we are solving for x using proportions. We've got an altitude that is dividing the hypotenuse, and so in that case, the altitude is the geometric mean, which means the value for the altitude, x, goes on the top on the left side, and on the bottom on the right. And then the other two parts that fill the other two spaces will be the 16 and the 4, the two parts of the hypotenuse. Once we have the proportion, then it's just cross multiplying. X squared equals 64. And then take the square root of both sides to get rid of the square on the x. And we end up with x equals 8. Right. Number 2, still kind of the same setup, except for instead of a value on the altitude, we got a value on the leg. And when we got a value on the leg can be the geometric mean. So the x goes on top on the left, bottom on the right. And then what goes in the other two places is not the two parts of the hypotenuse. It is the whole hypotenuse length, which will be 12. And the part of the hypotenuse that is adjacent to the leg, which is going to be the 3 there. Right. If we had the x down here on the bottom, it would be the 9 instead of the 3. Right. So once we got it set up, cross multiply, x squared equals 36, and take the square root of both sides, and x equals 6. Then number 3 and 4, finding the unknown side length, simplify our answers to the radicals and tell whether the side lengths form a Pythagorean triple. All right, so finding the side length, we're going to use Pythagorean's theorem. C squared equals a squared plus b squared, or you could flip that around, a squared plus b squared equals c squared, either way. So for this first one, our x is going to be where the c is, so x squared is going to equal 3 squared plus 7 squared, or x squared equals 9 plus 49. Add the 9 and 49, we get x squared equals 58. Take the square to both sides to get rid of the square. And it says to reduce the radicals if we can. 58, if we break it down, is 2 and 29. Those are both prime numbers. Can't go any further than that. So it's just x equals the square root of 58. And then to answer the question, is it a Pythagorean triple? So you got 3 and 7. And then the square root of 58, in order for it to be a Pythagorean triple, they all have to be whole numbers without a radical, a fraction, or a decimal in it. Since this one has a radical in it, then that means that it is not a Pythagorean triple. Or not a pith trip for short. All right, so then number 4, 20 would be the c. So 20 squared is going to equal 8 squared plus x squared, or 400 equals 64 plus x squared. Subtract that 64 from both sides, and 336 is going to equal our x squared, and then we take the square root and simplify the 336 if we can. It's even, so we know we can divide by 2 always if it's even. So 2 and 118, which is still even, so we can do 2 again. 2 and 59. 59 is prime. Leaves us with one set of 2's. So the 2's have a date. They get to go out. 59 is all alone. It stays home, right? So 2 square roots of 59 equals our x. And since we have a radical there, it doesn't matter whether the other numbers are whole numbers or not. This is not a Pythagorean triple. Then 5, 6, and 7. You have to do a couple things here. First, decide whether the numbers represent the side lengths of a triangle. And if they do, then we've got to classify them as right, acute, or obtuse. So first thing to decide if they make a triangle, the two smallest sides added together have to be bigger than the third side. Or in this case, 6 plus 8 would have to be greater than 10, which would be 14 is greater than 10, which works. So yes, we do have a triangle here. So now we have to determine what kind of triangle it is. So now we use basically Pythagoreans without the equal sign, because we're going to compare the two sides, the c squared and the a squared plus b squared. So, and for best results here, try to put the largest side on the left side. So 10 squared, we're going to compare that to 6 squared plus 8 squared, or 10 squared is 100, compared to 36 plus 64, which comes out to be 100 compared to 100, which is equal. And since those are equal, then that means it fits into Pythagorean's theorem, which makes that a right triangle. So then the next one, we've got the two smallest sides, 2 and 5, have to add together to be greater than 6, which 7 is greater than 6. So yes, it is a triangle. And now what kind of triangle is it? We're going to say 6 squared compared to 2 squared plus 5 squared, or 36 compared to 4 plus 25, or 36 compared to 29. So 36 is greater than 29. And since the c squared term is greater than the a squared plus b squared, then we know that this is an obtuse triangle. If c squared is less than a squared plus b squared, then it's a acute triangle. And of course, we already know if it's equal, it's a right triangle. And number 7, you got 1, 2, and 3. So 1 plus 2 has to be greater than 3. Which when we look, we get 3 greater than 3, which is not true. Since 3 is not greater than 3, it's not a triangle. All right, so find the value of each variable, write the answers in simplest radical form. All right, so now we've got special right triangles, and each type has a different set of rules. First one is a 45, 45, 90 special right triangle. And so the rule we have to remember from there is that the hypotenuse is equal to the square root of 2 times a leg. And since it's a 45, 45, 90, that means it's isosceles, which means that the two leg lengths should be the same. So when I look to solve for x, since it's a leg, then it should be the same length as the other leg, and we know the other leg is 6, so x is going to be 6. And then from there, y, which is the hypotenuse, should be equal to the square root of 2 times a leg, and we know the legs are 6, so y is equal to the 6 square roots of 2. So x is 6, y is 6 square roots of 2. Number 9, it's a 30, 60, 90. So we got two new rules for 30, 60, 90. First, with the hypotenuse, it's equal to 2 times the short leg. And then the long leg is going to be equal to the square root of 3 times the short leg. Everything's compared to the short leg on the 30, 60, 90. So, starting off, 5 is a hypotenuse, A is the short leg, and B is the long leg. So, the hypotenuse should be equal to 2 times the short leg. So 5 should be equal to 2 times the short leg, which is A. So to solve for A, we divide by the 2. And our A value is going to be 5/2. And then the long leg, B, should be equal to the square root of 3 times the short leg, or the square root of 3 times 5/2. So B equals square root of 3 times 5/2. Or B would be 5 square roots of 3 over 2. And if you took those to decimals, then your A would be 2.5 and your B would be 2.5 square roots of 3. Just a little more appropriate to not have a decimal in front of your radical sign. So fraction looks a little more appropriate. All right, number 10. We got two 30, 60, 90s stacked on top of each other. And so we've got a short leg of 8 trying to get to X down on the bottom, which is a long leg. And in order to get there, we're going to have to go from that short leg to the bottom side, which is a long leg. But when we switch over to the other triangle, then that long leg is now a hypotenuse. And we'll have to go from that hypotenuse to the other short leg. And then we can go from the short leg to the long leg. So 1, 2, 3 steps. So starting with 8 as a short leg, going to the long leg. So the long leg is equal to the square root of 3 times the short leg, which is 8. So we get 8 square roots of 3. And now we look at that as the hypotenuse of the bottom triangle. And the hypotenuse is 2 times the short leg. So 8 square roots of 3 is the length of that hypotenuse. And it's going to be equal to 2 times that short leg. So divide by the 2. 4 square roots of 3 is going to equal the short leg. 4 square roots of 3 there. And now that we know what the short leg is, we can move on to X, which is the long leg, basing it on the fact that the long leg is equal to the square root of 3 times the short leg. So X being the long leg is equal to the square root of 3 times 4 square roots of 3 for the short leg. And square root of 3 times 4 square roots of 3. I'm going to multiply the square roots of 3 and get rid of the radical, so it'll just be 4 times 3. Because the square root of 3 times square root of 3 is 9, and square root of 9 is 3. Right? So 4 square roots of 3, or 4 times 3, so X equals 12. All right, 11, 12, and 13, finding the sine, cosine, and tangent for acute angle A. Remembering our old hippies, right? Some old hippie, SOH. Sine equals opposite over hypotenuse. Then caught another hippie, CAH. So cosine equals the adjacent over the hypotenuse. And tripping on acid, TOA. Tangent is equal to the opposite over the adjacent. So we're going to come up with these, and then you got to put them in a calculator because it wants them expressed to 4 decimal places. So starting off at 11 with A, the sine of A opposite over hypotenuse. 9 is the opposite side. 41 is the hypotenuse. And 9 divided by 41, 0.2195. Cosine of A is the adjacent side, which is 40, over the hypotenuse, 41. .9756. And then the tangent of A will be the opposite 9 over the adjacent 40, which is 0.225, but it wants it to 4 decimal places, so add a 0 in there to get it to 4 decimal places. And then 12, the sine of A. It's going to be the opposite side from A, which is 12, over the hypotenuse 20, which will be 0.6, but add 3 zeros to get it to 4 decimal places. Cosine of A will be the adjacent side 16 over the hypotenuse 20, which will be 0.8. Put in the zeros to get it to 4 decimal places. And tangent of A will be the opposite side 12 over the adjacent side 16. So 12 over 16, 0.75, 0, 0 to get it to 4 decimal places. And 13, A is here, opposite side is 25. So opposite 25 over the adjacent, or opposite over the hypotenuse, which is 65. So 25 divided by 65, 0.3846. Cosine of A, the adjacent side 60 over the hypotenuse 65. 0.9231. And tangent of A is the opposite side, 25, over the adjacent side, 60. And 25 divided by 60 is equal to 0.4167. So in the next group, we're solving for missing parts of the triangle. 14, they give us a 24-degree angle. They give us an 8 on the opposite side from that 24-degree angle, and X is on the hypotenuse. And so opposite and hypotenuse fits into sine. So we're going to use the sine of 24. The opposite side over the hypotenuse is what sine is equal to. So sine of 24 is going to equal the opposite side 8 over the hypotenuse of x. So now we've got it set up. Now we multiply both sides by the x. We have x times the sine of 24 equals 8. Divide by the sine of 24. So 8 divided by the sine of 24 is 19 point, rounds it to the 7, to 1 decimal place to the tenths, so it's 19.7. Then next one, got a 35-degree angle. X is the opposite side, 17 is the adjacent. So trig function with opposite and adjacent is tangent. So tangent of 35 is going to equal the opposite side x over the adjacent side 17. Multiply both sides by the 17. Get it out of the denominator. So 17 times the tangent of 35 equals x. And 17 times the tangent of 35 is going to give us 11.9 equals x. All right, so those two we're solving for a side. The next two we're solving for an angle. And for the angle, if you look at the angle, the x is there, and 29 is opposite, 14 is adjacent. Opposite and adjacent goes with tangent. So we're going to say the tangent of angle x is equal to the opposite side 29 over the adjacent side 14. And so since we know what the tangent of the angle is, we can plug that tangent value into the inverse tangent, and that will give us the angle. So x is equal to the inverse tangent of 29 over 14. So second function tangent button gives you the inverse, and then 29 divided by 14, x equals 64.2 degrees. And lastly, we got an x. 40 is on the adjacent side, 42 is on the hypotenuse. So the trig function that goes with adjacent and hypotenuse is cosine. So the cosine of x is going to equal the adjacent side 40 over the hypotenuse 42, which means that x is going to be equal to the inverse cosine of whatever 40 over 42 is. So second function cosine 40 divided by 42, and x is going to be 17.8 degrees. And that completes the review.